Hello guys, today we are going to discuss about cubic crystal system. Okay, cubic crystal system. Let us try to understand some basic concept about the crystal structure. What is crystal structure? Crystal structure is obtained by attaching a constituent particle to each of each other through a lattice point. See a diagram. These points are known as lattice points. What is meant by lattice point? These points are geometrically arranged in three-dimensional periodic array, and these points represent lattice points or constituent particles. Means the lattice points is equal to constituent particle. If we join this lattice point in a straight line, a structure is obtained. This structure is known as a crystal. Here a single structure is obtained which is known as cube or unit cell. This structure is known as cube or unit cell. This is a three-dimensional arrangement of constituent particles. Constituent particles may be atoms, ions or molecules. Okay. Now, you may be thinking about what is meant by crystal lattice, because if we repeat this structure so many times, we get a giant structure, and that structure is known as crystal lattice or space lattice. So, what is meant by lattice? Okay, what is meant by lattice? See, if we consider this structure is repeated so many times. For example, अगर हम कंसीडर करते हैं हमें एक दीवार बनानी है, ठीक है, तो दीवार कैसे बनेगी? उसमें बहुत सारे ब्रिक्स हमें अरेंज करने पड़ेंगे. तो जो ब्रिक्स हम रखेंगे, हम कैसे भी रखेंगे क्या? नहीं, उसको एक वेल ऑर्डर मैनर में रखेंगे. And this brick, a single brick, is considered as unit cell. Actually, the structure of wall is not the three-dimensional arrangement, but for our sake of convenience, to understand the concept of crystal lattice, we consider the example of wall. So, the single brick is known as unit cell, and after arranging that bricks, we get a giant structure which is known as crystal lattice. समझ में आया? मीन्स अगर हम एक ब्रिक कंसीडर करते हैं तो वो बन गया यूनिट सेल. ओके, एंड जब पूरी दीवार बन जाएंगी तो वो बन गया क्रिस्टल लैटिस. सेम हियर, अगर हम इस क्यूब को अरेंज करते हैं थ्री डायमेंशन में तो हमें एक स्ट्रक्चर मिलता है, उसे बोला जाता है क्रिस्टल लैटिस. ओके, देयर आर सो मेनी वेज टू ड्रॉ द क्रिस्टल लैटिस, but I am going to tell you the very easiest method to draw the crystal lattice. Now see, first when we consider a cube, this is a cube or unit cell. What is meant by this unit cell or cube? Unit cell is the basic structure, or you may call the smallest part of a crystal lattice. The smallest part of a crystal lattice, it is known as unit cell. When we consider unit cell or cube, cube has corners. A cube has corners, edges and faces. How many corners, edges and faces possesses by a cube or unit cell. Let us see. This is a cube. These 4 points are the corners of a cube. Similarly, 4 points from upper side, 4 points from lower side. So total 8 corners are there. This is a cube. Okay. This is the first corner, second, third, fourth. 4 corners from the upper side, 5th, 6th, 7th and 8th. 4 from the lower side. In this way, there are 8 corners possessed by a cube. Second, edges. Total 12 edges are there. See, first, second, third, fourth. 4 from upper side, 5th, 6th, 7th, 8th. 4 from lower side, 1, 2, 3, 4 and 4 from the side. See, total 12 edges are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. In this way, 12 edges are there. See again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. In this way, 12 edges possessed by a cube or unit cell. Then faces. Total 6 faces are present in a cube or unit cell. First, second, third, fourth. 4 from side, 1 from the upper side, 1 from below side. How many faces are there? Total 6 faces are there. First, second, third, fourth, fifth and sixth. In this way, a single cube has 6 faces. 1, 2, 3, 4, 5 and 6. 6 faces are there. So, a single cube or unit cell possesses 8 corners, 12 edges and 6 faces. Okay. Now, this unit cell is divided into 7 types of crystal structure depending upon 2 parameters. That parameters are edge length and angle. The crystal system is divided into 7 types of crystal, that is depending upon the edge length or dimensions and angles. Edge length, see here, this is the edge length denoted by A, B, C. These are also known as dimensions. Edge length or dimensions denoted by letter A, B and C. And the angle between them, angle between B and C is alpha, C and A beta, A and B gamma. So depending upon these 2 factors, cubic crystal system basically divided into 7 types. 7 types of crystal system. See here, types of crystal system. C, T, O, M, T, H, R. This is the short form. How to remember the 7 types of crystal system. C stand for cubic, T stand for tetragonal, O for orthorhombic, M for monoclinic, T triclinic, H hexagonal and the last one is R stand for rhombohedral. These are the 7 types of crystal system. Out of these 7 types, we are going to discuss about only the first, that is cubic crystal system. Okay, so this is about the cubic crystal system. Now what is meant by cubic crystal system? As we know that the types of crystal system based upon two parameters, age length and angle. So when we consider the cubic crystal system, then for that the age length A is equal to B is equal to C, means all the three edges must be equal. Okay, this is the first point. Cubic crystal system must possesses all the three edge length or dimensions equal. We write A is equal to B is equal to C. And then angles, alpha is equal to beta is equal to gamma is equal to 90 degree. The angles between them are perpendicular to each other or 90 degree. So what is the basic condition for cubic crystal system? All the three edges must be equal and the angle between them is perpendicular to each other. So this is cubic crystal system. As we know that the constituent particles possesses by a cube. Depending upon that, there are three types of crystal lattice, cubic crystal system. Okay, three types of cubic crystal system. The first one is simple or primitive cubic unit cell, in short SCC. Second, body centered cubic unit cell, BCC. Third is face centered cubic unit cell, FCC. These are the three types of cubic crystal system: simple cubic unit cell, body centered cubic unit cell, face centered cubic unit cell. Now let us see what is meant by simple body or face centered cubic unit cell. As we know that the 8 corners of a cube possesses by a constituent particle. When we consider the SCC type of cubic unit cell, means simple cubic unit cell possesses the constituent particles at each corners only. At each corner, total 8 corners are present. If the constituent particles are present at corners, that type of cubic crystal system is known as simple cubic unit cell. Second, BCC. BCC means body centered cubic unit cell. Along with the corner particles, if one of the constituent particle present in the center. Along with corner particles, one particle is present in the center. Such type of crystal system is known as BCC, body centered cubic unit cell. Third one is FCC, face centered cubic unit cell. The 8 corner particles are as it is. There are 6 faces are present. If at the center of each face the constituent particle is present, then such type of structure is known as FCC. Total 8 corner particles are as it is. 8 corner particles are as it is. Okay. Eight corner particles are as it is. Along with the 8 corner particle, one particle is present at the center of each face. It is known as FCC, that is face centered cubic unit cell. Now we are going to lattice. This is the structure of crystal lattice. If we draw these 3 points, okay, join these points vertically and horizontally, we get a structure. Draw the point just below the point near about 45 degree. Again join these points vertically and horizontally. Okay, again draw these points just below the given structure and we get a structure of crystal lattice. Join these points vertically and horizontally. Then join it diagonally also. Join these points diagonally. In this way we get a structure which is known as crystal lattice. This is a structure of crystal lattice. This crystal lattice consists of 8 cubes. 2 at the upper side, 2 at the below side, means from the front side we will get 4 cubes and same from the back side. In this way this crystal lattice consists of 8 cubes. See, if we consider the cube, this is a single cube. Same from this side, means at the upper side we get 2 cubes and at the lower side we get 2 cubes. Front side consists of 4 cubes and same for the from the back side. In this way this crystal lattice consists of 8 cubes. Now if we consider the sharing of particles, these constituent particle shared by how many cubes? The first one, if we consider the corner particle, suppose this is the corner particle, it is shared by 8 cubes. Corner particles are shared by 8 cubes. अब आप बोलोगे कैसे? देखो, corner particle, suppose this is a constituent particle present at the corner. This is the corner of this cube. It is shared by the left side cube also. Same from the bottom side, 2 cubes. So in this way from the front side this corner particle is shared by 4 cubes. Same from the back side. So in this way a corner particle is shared by 8 cubes. Okay. Then edges. Edges are shared by 4 cubes. कैसे? देखो, if we consider this is a edge of the cube, it is shared by this cube. Same from the left side, means from the front side edge is shared by 2 cubes. Same from the back side, it is shared by total 4 cubes. And last, faces. Faces are shared by only 2 cubes. If we consider this is a face, okay, this is a face, it is shared by this cube and the left side cube, means faces are shared by only 2 cubes, right and left side. In this way the sharing of the cubes, constituent particles are shared by these numbers of cubes. Corner shared by 8 cubes, edges shared by 4 cubes and faces shared by 2 cubes. So this is about the cubic crystal system. Now see once what is meant by cubic crystal system. If A is equal to B is equal to C. All the edge lengths are same and the angle between them must be perpendicular to each other. Then there are three types of cubic crystal systems: simple cubic unit cell, body center cubic unit cell, face center cubic unit cell. Simple cubic unit cell means at the 8 corners constituent particles are present. At the 8 corners, the simple diagram of the simple cubic unit cell, at the 8 corners constituent particles are present. BCC, at the 8 corner constituent particles are present along with the one center particle, and this is the FCC. FCC, 8 corner particles plus 1 at the center of each face. So, this is about SCC, BCC, FCC. No doubt for these three the same value for the edge length and angle. And I hope that this will definitely help you to understand while studying the solid state. Okay, thank you.